Welcome to class. We want to look at balancing of redox equation in acidic medium. In our last class, we actually looked at balancing of redox equation ordinarily. Today, we are looking at balancing of this redox equation in acidic what? Medium. In acidic medium. Okay. I'm going to take one example. This balancing of this equation in acidic medium. Yeah. Okay, I'm going to give a particular equation, but when you look at it, you must first of all identify if it is a redox equation. If it's a redox equation, you move on. Let us use that of this equation, manganese ion. Let us go like this. I have this plus Fe2 plus, moving to M2 plus, Mn2 plus, then plus Fe3 plus. Look at that equation. Look at that equation. Is it really a redox equation? Because that is the most important thing. Is it a redox equation? Let's check. I have manganese here. Coming to my right hand side, I have manganese ion here. Inside this compound, there's manganese. And here, there's also manganese. What is the oxidation number here? And what is the oxidation number here? Looking at that, you will notice the oxidation number here is plus 7. Why the oxidation number here is plus 2? Why here is plus 7? Let's see. I'm looking for manganese plus oxygen gains 2 electrons times the 4 here, all is equal to the charge. Then the manganese ion, or the manganese itself, plus minus is minus, 2 times 4 is 8, all is equal to minus 1. So what is Mn? Mn is what? Minus 1. Minus 8, crossing sign of equality becomes what? Plus 8. So the answer is what? Plus 7. So the oxidation number of manganese here is plus 7. Coming here is what? How many? Plus 2. What happened? Decrease in oxidation number. That means that is what? Reduction. Now let's just take ion. Ion has plus 2 here, which means oxidation number is plus 2. How many here? Plus 3. Oxidation number here is plus 3. What happened? There is an what? Increase in oxidation number from left to right. That is what? Oxidation. That tells us that that equation is a redox what? Equation. So what do you do next? I believe you have looked into the previous lesson where I stated that you separate the two. Separate the two. I'm going to separate the two now. I'm going to separate the two. Let me pick Fe2 moving to what? Fe3 plus. First of all, balance in terms of atom. Forget about the charges now. How many atoms of ion do I have here at my left hand side? 1. And how many atoms do I have at my right hand side? Also what? 1. I say forget about the charges. The charges will have a different way of what? Balancing it. Now, I have plus 2, I have plus 3. Right? In terms of atoms, they are balanced. In terms of charges, I mean what they carry on top, are they balanced? No. Plus 2 here, plus 3 here. You have to balance it. Remember, you balance charges by introducing electron. Where will the electron go? Electron move to the direction you have a higher positive number so that it draws it down and the total becomes equal to the other side. So what's the difference between plus 2 and plus 3? Just 1. So you introduce 1 electron to where you have plus 3. So I have what? Electron minus. Electron what? Minus. Can you see that? Electron minus. So if you check it now, you have plus 2 here. If you calculate here, you have plus 3. This minus is this. And once is 1, here is 1. So what is the value? Plus what? 2. So both sides are now balanced. Check it. Both sides are now balanced. What did I do? I introduce electron to where I have more higher number. So it reduces it and makes it equal to the other side. So I have balanced this oxidation half equation. I have balanced it both in terms of atoms and in terms of what? Charges. In terms of atom, in terms of charges. Remember to identify which reaction. This is oxidation half equation. This is what? Oxidation what? Half what? Equation. Oxidation half what? Equation. Now, it is balanced. In terms of atoms, one atom of iron, one atom of iron. I have balanced the charges by introducing one electron here so that it reduces +3 to +2. I will now pick up the next part of this equation, which is the reduction half reaction, which starts with MnO4 minus, right? Then moving towards Mn2+. Please pay attention to this. When you are balancing the equation in acidic medium, the moment you see the presence of hydrogen and oxygen, we have special way of balancing them. That is what, actually differs from the previous one we did when we balance equation without taking it in acidic medium. Okay, we just balance oxygen there, we just balance it just like that. But when you are balancing in acidic what? Medium. Once you see hydrogen, once you see oxygen, leave them. Okay, just allow them to be. Balance others. Just balance others. As I said, look at it. Step 2 said, identify oxidation half reaction equation, which we identify. Then you identify the what? Reduction half equation. Okay. Okay. Identify the reduction half equation. We have already identified both of them. After that, you now begin to balance. We have balanced the oxidation half equation in terms of atom and in terms of charges. Now we are in the what? Reduction half equation. But that reduction half equation contains oxygen. So you just have to leave it and balance every other atom there that is not oxygen and hydrogen. So let's go. Apart from oxygen here, we have manganese here. So let's balance. Manganese here is just one atom at my left-hand side. And there also one atom at my what? This particular side. So do not interfere this with number of atoms. No. The atoms of manganese here is just what? It's just one. Here is one. So in terms of atom is balanced. Now you move on to balance what? Oxygen. How then do you balance oxygen in acidic medium? Pay attention to this. Pay attention to it, because if you miss this, you can't be able to do it. You can't be able to do it. What do you do to balance oxygen in acidic medium? In acidic medium. Ask yourself, where is that oxygen? Looking at it, this oxygen is where? At my what? Left-hand side. How many atoms of oxygen there? Look at it, just 4 atoms. Because you have 4 atoms of oxygen at this particular side, the left-hand side, the reactant side. You are going to introduce 4 molecules of water. That's the rule. I have 4 atoms of oxygen here. I'm going to introduce 4 molecules of water the other side. So let's go. Plus 4 molecules of water. So I have 4HO. That is the rule. Once it's in acidic medium, you see oxygen. Calm down. Take care of the other ones. Take care of the other ones. In terms of their atoms, take care of the other ones. In terms of the atom, after that, now pick up the oxygen and later pick up the hydrogen. When you are done with them, you now balance all of them in terms of charges. So that means you shouldn't balance in terms of charge when you have taken care of only manganese. Manganese you are balancing in terms of atom first. Then you are seeing oxygen there. Balance oxygen with the special way we balance oxygen. Which way do we balance oxygen? How many atoms of oxygen do you see there? I see 4. Where? At my left-hand side. So I'm going to carry 4 molecules of water and put in the other side, which I have done. Have you seen it? Fantastic. Now, introducing 4 molecules of water, there's an element that you have invariably brought in. What is that element? Hydrogen. Because hydrogen is part of the what? Water molecule. Check. Watch it. How many hydrogen? You see, hydrogen is in now. Why? Because you are trying to balance what?
oxygen by putting molecule of water. Why are we putting 4 molecules of water? Because there is 4 what? Atoms of oxygen. So this 4 will definitely balance oxygen atom here. But how many hydrogen finally have you succeeded in bringing in? You have finally brought in what? 8 atoms of hydrogen. 4 times what? 2, which is what? 8. What does that mean? You are going to put hydrogen ion, not just ordinary hydrogen, 8 hydrogen ion to the other side, because the 8 hydrogen atom already is where? At my right hand side. So 8 hydrogen ion will now move to this direction. What do I mean? This side now, you have what? Plus what? 8 H what? Plus. Not 8 H molecule of hydrogen, but ion of hydrogen. 8 H what? Plus. By doing that, it corresponds to the number of hydrogen you have at the what? Right hand side. With this now, with what you have done now, you have to check the what? The total charges here and the total charges here. Let's see. Now follow me. We are done with in terms of atom, both manganese, oxygen, and even hydrogen that is introduced. We are going for charges. Let's see. This MnO4 minus is just minus. So the minus interacting with 1 here. So I have minus 1. This is plus, which is plus 1. Interacting with this 8, I have plus what? 8. So what do I have in all? Minus 1 plus 8 is what? Plus 7. Plus what? 7. Let me go to the other side. Let me go to the other side. How many do I have? Just this. There's no charge here. I just have only what? Plus what? 2. So if I have plus 2 at my right hand side and I have plus 7 at my left hand side,
where do I have a greater number? At my left hand side. How do you balance it? Based on our previous lessons, you balance by introducing an electron to where you have a higher number. That electron carries negative. Electron will draw that number what? Down. So that it becomes equal to this side. Now my question is, how many electrons do you think I'm going to place this side? I'm going to rewrite this. MnO4 minus plus 8H plus. It is
going to put the electron this side. How many electrons? We drag this plus 7 to what? Plus 2. That is 5. So I have plus 5E minus, right? Then I will draw my arrow and move over to this side. So I have Mn what now? 2 plus what? 4 molecules of what? Water. With this, the total charges here will give us what? Plus 2. Y here will give us what? Plus 2. Okay. With this, the reduction half equation is balanced. The reduction half equation is balanced. This is reduction half what? Equation is balanced. Reduction half equation is balanced. Oxidation half equation is what? Balanced. What is the next thing to do? What is the next thing? What do you do next? You have to check each of the half equation. Do they contain the same number of electrons? My oxidation half equation has just 1 electron. Why my reduction half equation has how many electrons?
5 electrons. They must be equal. They must be what? Equal.
They must be equal. What do? You have to use this 5. Look for a factor that will multiply the order so that everything will have equal number of electrons. Both they have reduction half equation and oxidation half what? Equation. To say, coming to this point, I have data. Permit me to take care of this. You have noted that this is oxidation half equation, right? Okay. You have also seen that this is actually coming from here, right? So if I remove this, these are the 2 equations I have now. These are the 2 equations. This is also reduction half equation. You know about this. Okay. Okay. So what do? I have 5 electrons here, while I have what? How many? 1 here. So what do? This equation will be multiplied by what? 5.
The aim is to do what? Make sure that I have 5 electrons. So all of these will be multiplied by 5. So 5 will enter here, 5 will come in here, and the 5 will come in here. Right? So what do? Now this is 5 electrons, and here is also 5 electrons. So this and this will take care of themselves. Okay, what do you do next? Join the whole equation together and you check the atoms and the charges. join the whole equation together. So I'm going to join them. Permit me to bring this one
a bit higher so that we can see what is here. So I have MnO4 minus plus 8H plus 5 electron. Then I have Mn2 plus 4 molecules of what? Water. This is what I have. Do now, I'm going to bring the two of them together. The two have equations, after which I will check
if both are balanced. What do I do?
You rule a line, then bring all the reactants. Let's begin by writing the reactant. In the reactant of oxidation half equation, I have iron, so that is 5Fe2
plus. I'm done with the reactant here. So I move to the reactant of the what? The other half equation, okay, which is now plus what? MnO4 minus plus 8 hydrogen ion. There's no need of picking this, but this has taken care of this. 5 electron has cancelled 5 electron, right? So move to the product side. As you move to the product side, move to the also the oxidation half equation, which is what? 5Fe3 plus. This is taken care of. So move to the product side of the what? Reduction half equation, which is what? That is plus Mn2 plus 4 molecules of what? Water. This is the overall equation, but you have to check whether both sides are balanced. Now let's move in terms of atom. In terms of atom, I have 5 atoms of iron here. Let me move to the right hand side. 5 atoms of iron. Forget about their charges for now. Manganese, I have only 1 here at my left hand side. Manganese, only 1 here at my right hand side. Let me move to oxygen. Oxygen, I have 4 atoms at my left hand side. Oxygen, of course, you know that this 4 concerns everything here. So oxygen here is also 4 at this side. How many hydrogen do I have at this side? 8 atoms of hydrogen. Let us check this side. I have 4 times 2, which is what? 8. Everything about atoms, the left hand side and the right hand side are balanced. Let us now check the charges. Let's check the charges. I have plus 2 here. The plus 2 will interact with this 5, which gives me plus 2 times 5. I have plus 10. Plus, this is minus, which is minus 1. Any number here is 1. So minus 1 times 1 is 1. Plus, this is plus, ordinary plus. Multiplying 8, I have positive 8. So what will the total number give us? Okay, quickly do that. So we have 11. 10 plus 1 is 11. 11 plus, okay, sorry, minus interacting with plus. Sorry, here is minus. Here is minus. So 10 minus 1 is 9. Then 9 plus 8 will give us what? 17. 17. Let me now go to the, so I have plus 17. Where? At my left hand side. So let us see what we're going to get by this particular, that's at my right hand side. Plus 3 multiplying 5 will give me 15, plus 15. Then plus, positive 2 times 1 is 2. So 15 plus 2 is equal to what? 17. Which means I have plus what? 17. What have you observed? Both sides are balanced in terms of charges and in terms of what? Atoms. In terms of charges and in terms of atoms. In terms of charges and in terms of atoms. Okay, we are done with that. Can we quickly do this one? Can we quickly work on this? Let's quickly work on this and see. We're going to be fast because you have the knowledge now. You have the knowledge. I'm going to give you a redox equation. A redox equation quickly. Let me look at this. Okay, shall we use the same Fe? Let's go by this one. Cr2. Okay, no problem. Let me go by this. I have H2C2O7 reacting with MnO4 minus to give me CO2 then plus Mn2 plus. Okay, if we have this, we have to identify the oxidation and identify the reduction. Without wasting time, I can see carbon here. and I can see carbon here. So let's relate carbon here to here. Let's find the oxidation number of carbon here, and then find the oxidation number of carbon here. Looking at it, I know definitely that I have how many oxygen here? 7. But here I have how many? 2. Decrease in oxidation number, that is, oxygen is actually removed. So I don't need to be told that from here to here. Okay, we need to calculate it anyway. Let's calculate. Hydrogen is losing 1 electron plus 1 times 2 plus carbon, I'm looking for carbon 2C, then plus oxygen, which is minus 2 times what? 7. All is equals to what? 0. Remember the rules in calculating oxidation number. I'm looking for this particular one, which carries C what? 2. Okay, I multiply the 2 times C, which gave me what? 2 what? C. So looking at this now, I have 2 here plus 2C plus minus is minus 2 times 7 is 14, all is equals to 0. So I'm looking for 2C, looking for carbon, which is equals to minus 4 crossing side of equality will give me what? Positive what? 14. Then these 2 coming here will give me minus 2. That is my 2C is equals to what? 12. What is my C? My C is 12 all over what? 2, which is equals to what? Plus what? 6. Plus what? 6. Okay. The oxidation number, is it really a redox reaction? Looking at it, here is 6, and here is 4. Is reduction. And here is 7, here is 2. No, two of them cannot be, because it cannot be reduction and reduction. Okay. We need a redox equation that one side is acting as oxidation and the other side is acting as what? Reduction equation. Okay, let's look at the CR2O7. Okay, moving to, okay, reacting with Fe2. Then the products are CR3 plus, then plus Fe what? Fe3 plus. What I change here now is this. The other one we use MnO4 for this. Now I have changed it to what? CR2O7. This equation is like this. So what do I have here as a power? Let's check. If I have 2 minus here, and then coming here to have what? CR2. Let us check the oxidation number. Let us check the oxidation number. So looking for chromium, chromium is 2Cr plus oxygen is minus 2 times 7. All is equals to minus what? 2. Let's check. All is equals to minus 2. So here, what do I have now? I have 2Cr, which is chromium, minus 14 is equals to minus 2. So my 2 chromium becomes equals to minus 2 plus 14, right? That is my 2Cr is equals to what? 12. Cr is equals to 12 divided by 2, which is equals to plus 6. Okay. Here, oxidation number of chromium here is what? Plus 6. Why here is plus what? 3. That means reduction. Why here, oxidation number of iron is plus 2. Here is plus 3. That is what? Oxidation. This must be ascertained. This must be, the fact must be established that it's a redox equation. Both of them cannot be reduction, or both of them oxidation. If that happens, that means you are not dealing with a redox what? Equation. Now, this has been established to be a redox what? Equation. What do? We separate the what? We separate the two. So from CR2O7 2 minus to what? CR3. From oxidation number of plus 6 to oxidation number of what? Plus 3. What do I have there? That is oxidation half equation. Oxidation half equation. Oxidation half what? Equation. It's clear. So this one now is Fe2 plus moving towards Fe3 plus. From plus 2 to plus 3. No, this was plus 6 to plus 3 is reduction. The number reduced. Reduction. Don't make that mistake. Now, why from plus 2 to plus 3 is oxidation? Because the number actually increased. Don't forget the definitions we are given earlier on. Now, after this identification, You move on to pick them one after the other. I am going to still solve for the oxidation first. So I'm going to take care of the oxidation first. This is the oxidation. I'm going to pick the oxidation first. Oxidation is from ion 2 to ion 3. Let's go. Make sure your mind is here. Watch what we are going to do now. From Fe2 to Fe3, what has happened? In terms of atoms, we have just one atom of iron at my left hand side, equally one atom of iron at my right hand side. Can you see that? In terms of atom, both sides are balanced. Let's go to in terms of charges. What's the charge at my left hand side? +2. Going to my right hand side, I have +3. What do I do? Introduce electron, a negative value that will draw that one down. So what is the change here? What is the difference? The difference is what? Just 1. So I'm introducing 1 electron to where I have the higher power. So that is what? 1 electron. With this, I have balance in terms of atoms and in terms of charges for this particular oxidation half equation. Full stop. I will now move to the reduction half equation. Quickly, let's go. CrO2O7, 2 minus, going to what? CrO what? 3 plus. Let's go. In terms of atom, watch critically. This one is a bit somehow different. At my left hand side, I have 2 atoms of chromium. But at my right hand side, I have just 1 atom of chromium. What do I do? These 2 will now appear here. Can you see that? Can you see where you balance in terms of atom? You don't tamper with the formula. You don't do that. Where you want to balance in terms of atom, where you put your number is by the mole side. You don't, if you go on to put any number in the other side, that means you have actually changed the stated formula of that compound. So you saw where I put my 2 to make sure chromium has 2 atoms here and also 2 atoms here. That is fantastic. Now, let me balance in terms of charges. Look at the charges. What charges are we talking about? Look at the power here. Here is carrying what? 2 minus. If it interacts with 1 here, that is -2. If I come here, I have this 3 plus interacting with this, I have plus what? 6. What is going on? -2 here, plus 6 here. Where do I have a higher number? I have a higher number at my right hand side. That is where I will introduce my what? Electron. To bring it down to what? -2. To bring it down to what? -2. So what do I do to do that? What am I going to do? I am going to do what? Place the number here, which is what? How many electrons are we going to place here to balance the stuff? Check very well. Okay. I have +6 here and I have -2 here. That's going to be 8. 8 electron plus 8 electron. So I have +6 -8. That will give me -2. That will give me what? -2. So I'm having 8 electrons. So I'm going to have what? Plus what? 8 electrons. Plus what? 8 electrons. So watch it now. Plus 8 electrons. So I'll be having +6 -8. That will give me -2. So in terms of atoms, it's balanced. In terms of charges, it's also what? Balanced. So what do I do? What is now the difference between here and here in terms of electron? The difference is what? This particular 8. So I'm going to multiply the whole of this by what? Times what? 8. And once I do that, I will have 8 here, I will have 8 here, and I will have what? 8 here. Can you see that? Can you see that? The essence of doing that is to make sure that both sides gives you equal number of what? Electron. Both sides gives you equal number of what? Electron. So what do I do now? Watch it critically. What do I do? I have 8 electrons here, and I have 8 electrons here.
Okay, as I was saying, in terms of atom, it is balanced. Chromium is what? Okay, chromium is what? 2 atoms of chromium. Why that of the chromium at my right hand side originally was what? 1. So I have to balance it by putting what here? 2. Right? So having done that, we now balance the charges. Before you balance the charges, remember there is an element there called oxygen. Do not forget what I told you about oxygen. Oxygen has a special way of balancing it. What do? How many atoms of oxygen do I see here? I see how many? I am seeing 7 atoms. Where? This side. So I'm going to introduce 7 molecules of water by my right hand side, which is 7 molecules of what? Water. Have you seen how we balance oxygen? So oxygen is how many? 7 atoms. So I'm going to put 7 molecules of what? Water, which balances oxygen. If that is the case, you have introduced hydrogen. How many hydrogen are? 7 times what? 2, which is what? 14. That means I'm going to put 14 hydrogen ion. We'll balance hydrogen atom using hydrogen ion. How many? The number you'll be able to get here, 7 times 2, which is what? 14. So here becomes what? 14 hydrogen what? Ion. In that case now, check the charges here and check the charges here. The difference, you make it up with what? Electron. Okay, I have -2 here coming from here, then plus 14. That means plus 1 here times 14 is what? Plus 14. The whole value will give me what here? -2 plus 14 is what? Positive what? 12. Let me come to this place. Plus 3 times 2 is giving me what? Plus 6. Plus 12, plus 6. Where do we have bigger number?
At my left hand side, plus 12. That is where you introduce an electron to reduce it. Are you following that? Yeah. So I will rather put the electron where I have a higher number. I will now put the electron here. Are you seeing what is going on? How many electrons will I put? Remember, electron will reduce the number. So what's the difference between 12 and 6? The difference is what? 6. So I'm introducing 6 electrons. I'm introducing what? 6 electrons. Fine. At this point, the next thing is check the electron you have. Okay. This is wrong. We have removed this. It's not 8. This is the actual number now. Watch it. This is the actual number. Soon we are going to exchange the number of electrons. Okay. How many electrons do we have here? We have 1 electron here. Okay. How many do we have here? 6. You have 1 here. You have 6 here. So what are you going to do? You look for a factor, a number that we will use to multiply this so that all of them will become what? 6.
Okay. So if I multiply this by 6, so here becomes what? 6, 6, and what? 6. Meaning that here and here are what now? Equal. And finally, what do? Gather all of them together. So I will now bring all of them together, starting from this 6Fe2 plus the reactant you have exhausted. You will now pick the reactant of this plus CrO2O72 minus, then plus 14 hydrogen ion. Okay, we'll now move to the product side. Product side gives you for this 6Fe3 plus. Right? We are done with this. Then plus 2CrO3 plus. Then plus
7 molecules of water. 7 molecules of what? Water. That is the final balanced equation. But you must check, you must ascertain if it is balanced. You don't just conclude, you must check. How do you check? Let's go. 6 atoms of iron can be found in the left hand side. Let's go to the right hand side. 6 atoms of iron. Let's go to chromium. 2 atoms of chromium here. 2 atoms of chromium here. Let's go to oxygen. Oxygen, I have 7 atoms of oxygen. Here I have 7 atoms of oxygen. Hydrogen, I have a total of 14 atoms of hydrogen. 7 times 2 is 14. So everything is balanced. Now in terms of charges, very important, let's check. In terms of charges, plus 2 times 6 is plus 12. Minus 2 multiplying 1 is minus 2. And the plus multiplying 14 is what? 14. What will I have here? 12 minus 2 is 12 minus 2 is 10. So 10 plus 14 will give me 20 what? 4. Let me come to the right hand side. 6 times 3 is 18 plus 3 times 2 is 6. 18 plus 6, that is 24. That is correct. That is correct. You can see both sides are balanced in terms of atoms and in terms of charges. Thank you. You cannot see that the balancing of redox reaction or equation which students found or they think is difficult is an easy task. It's easy something you can do. The moment you put your mind and watch the steps, right? You will see. If you go step by step, you will see all I have done here. You will see them on the slide. On the slide here, we have one example, but you see, I gave you another example, which actually shows that it is very simple. Okay. Finally, before we go, let's just take one question. Let's just take one question. Just one question.
The question says, the reduction half equation of the following reaction is this. The reduction half equation. Which one is the reduction there? I have zinc moving to zinc sulfate. I have zinc moving to zinc sulfate. Zinc to zinc sulfate. So oxidation number of zinc here is 0. While here, this is 6. This is zinc tetraoxide sulfate 6. This is plus 6. So from 0 to plus 6 is oxidation half equation. And I have copper sulfate CuSO4 moving to ordinary Cu. This is copper 2 tetraoxide sulfate 6, which is from plus 6 to 0. That is reduction half equation. Reduction half equation. So it should be from copper 2 tetraoxide sulfate 6 moving to copper 2 ion. That is the reduction half equation. That is the reduction half equation. It cannot be copper 2, okay, copper 2 to ordinary copper. What is happening? That is the reduction. Copper 2 to ordinary copper, that is still reduction. Zinc to zinc 2, that is oxidation. So what do you think is the correct answer? They're trying to confuse you there. You can see what is happening from tetraoxide sulfate 6. The reduction half equation of the following reaction is this. Okay? The reduction half equation from zinc to this. Okay, that is from copper 2 to, okay, I told you that the two of them are confusing. Can you see it? From copper 2 to ordinary copper is reduction. Can you see that? Even from the one they marked wrong, you can see that here the oxidation number of copper here is plus 6 and here is plus 2. That is reduction. But other things are actually added there. Okay, let's look at the next question. Okay, what is the change in oxidation number of nitrogen? Oxidation number of nitrogen, the change, that's the last question we are going to take here now, which is 2NO plus oxygen moving to 2NO2 for that of the oxygen. Nitrogen, its oxidation number changes from here. Let us calculate where we have looking for nitrogen minus 2 equals to 0. That means nitrogen here is plus 2. Let's move to the right hand side. Looking for nitrogen plus minus 2 times 2 for oxygen equals to 0. That means N is equals to plus 4. From plus 2 to plus 4. That is the change. Plus 2 to plus 4. That is option C. Let's look at it. Plus 2 to plus 4. From nitrogen 2 oxide to nitrogen 4 oxide. That is correct. That is correct. And finally, look at the equation. Oh, that's fantastic. In fact, that is one of the redox equation we balance now. In the reaction represented by the equation, look at it. Which species is reduced? Which species is reduced? Every oxidizing agent is reduced, and every reducing agent is oxidized. Take note of this. Thank God for this question. This question you have to address something. Every oxidizing agent in a redox equation is reduced, while every reducing agent is being oxidized. So which one is a reducing agent there? Which one is a reducing agent? Which one is a reducing agent? And which one is oxidizing agent? So the oxidizing agent is what? Is reduced. Fe2 is not an oxidizing agent, is a reducing agent, so it's being what? Oxidized. Okay? Why Fe3 is oxidizing agent, which is being what? Reduced. Okay? Now from ion 2, what is from ion 2 to ion 3? That is oxidation reaction. That means MnO4 is an oxidizing agent and is being what? Reduced. Yes, it's being reduced. So this is an oxidizing agent. Okay? Since it's an oxidizing agent, it's being what? Reduced. It's being reduced. It's being reduced. Can you see that? That is correct. That is correct. That second question, that the two answers were almost corresponding. The best is copper 2 moving to ordinary copper, which is what? Reduction half equation. Okay. In the other one, you have CuSO4 moving to ordinary copper, what? 2. Moving to ordinary what? Oh, that's good, that's good, that's good. I think the mistake there was that I was looking at the oxidation number of what? Sulfur, because that is copper 2 tetraoxosulfate 6. Then I was comparing it with the copper at the right-hand side. Okay, so, but the question there demands that you should get what? That of the what? Copper. So it's from copper to copper. But the mistake there was we moved from sulfur to copper. So the correct answer there was from copper 2 to ordinary copper. That is a reduction. That is what? Reduction. Finally, pardon me, let's do this again. Finally, consider the reaction represented by the following equation. This is pure oxidation and reduction reaction. Look at it. You have, that's the last question we are going to attempt now. We have XKMnO4 reacting with YSO2 plus Z water, and that gives us K2SO4 plus 2MnSO4 plus tetraoxosulfate 6 acid. 2 tetraoxosulfate 6 acid. So watch it. Check now. You have to balance the equation. From the balancing, you will now get the number. So this has been balanced for you. 2 manganese, 2 moles of what? Manganese sulfate, 2 moles of what? Sulfuric acid, 1 mole of what? Potassium sulfate, Z mole of water, Y mole of sulfur dioxide, and S mole of this. So what do you do now? Let's go. Let's check. I have potassium here to be 2. So if I should put 2 here, for example, that balances this, and that has made manganese to be 2, which is also 2 here, making oxygen to be how many? 8. 2 times 4, 8. Okay. So how many oxygen do I have here now? At my right-hand side, I have 4 plus 8, 12. Then 12 plus 8. That is 20. I have a total of 20 oxygen here. Look at it. 4 plus 2 times 4, 8. 2 times 4, 8. 8 plus 8, 16 plus 4, which is 20. So I must get 20 oxygen here. That's what it means. Already I have 8 oxygen here because 2 times 4 is 8. 2 times 4 is 8. So how many am I going to have here? How many sulfur do I have here? Watch. I have sulfur how many? 1, 3 plus 2, which is 5. Which is 5. That means my Y is going to be what? 5. right? If my y is 5, I will now come to this side. How many hydrogen do I have here? I have how many hydrogen? Just 2. 2 hydrogen. So that means this is what? 2. Okay. That means our balancing is 2KMNO4 plus 5 molecule or mole of what? Sulfur 4 oxide plus 2 molecule of water. Then that gives us potassium tetraoxosulfate 6, which has 1 mole plus 2 moles of manganese sulfate, and finally plus 2 moles of tetraoxosulfate 6. Now let's check finally if it is balanced. Potassium here is 2. Let's go to the right hand side, is 2. Manganese manganese is 2 here. Let's go to this side, is 2. Balance. Sulfur is 5 at my left hand side. Sulfur here is 1 plus 2, 3, then 3 plus 2, 5. Balance. My hydrogen is 2 times 2, 4 here. 2 times 2, 4 here. Balance. Okay, that means the values are 2, 5, 2, 5, 2. 2, 5, 2. Do we have 2, 5, 2 there? 2, 5, 2. Let's check. 2, 5, 2 is option C. 2, 5, 2 is option C. That is correct. That is correct. You can't solve that problem if you don't have proper understanding of balancing of redox reaction and balancing in terms of atoms. Precisely, this one is balancing in terms of what? Atoms. Thank you for your time. Thank you for your time. And keep reading. Go over and over to this. You will discover that it is simple, no matter how the previous knowledge you had before, thinking that redox equation balancing is a difficult task. No, it is a simple one. So, till I meet you next. Bye.